Right. I want to summarize 3 crucial Gen AI concepts in this lesson. Clarifying these terms with an easy-to-understand example is helpful because people often use them interchangeably, even though they describe different activities. You might often hear, "We'll fine-tune the model," or "We'll use prompt engineering to improve the model's performance." Typically, they refer to one of 3 distinct methods: prompt engineering, RAG, or fine-tuning. All 3 techniques enhance an LLM's response accuracy and effectiveness in specific scenarios by targeting different aspects of AI functionality. Prompt engineering is when we explain to the model how to behave or what context to consider. We don't change any of its weights or add new data. We use instructions and provide verbal examples, explaining the desired output we want to obtain. This is fairly easy to do, and the best part is that we can consistently refine our prompts through multiple iterations to achieve satisfactory AI outputs. It's important to note that the model doesn't change. It merely adapts to our verbal instructions. Retrieval Augmented Generation, or RAG, is another technique that doesn't change the model's weights. With RAG, we attach a database to the model, which can be used as a library for expanded context. This method provides significantly more examples of how the model can be used to learn to perform optimally. RAG and prompt engineering are effective, but making an LLM smarter or faster is unlikely without modifying its weight. This complex task requires additional training for an already trained model. This process is known as fine-tuning. Sometimes extra data is required to conduct fine-tuning. Moreover, fine-tuning can be computationally expensive, and we can't use an iterative process like prompt engineering and adding RAG. Let me explain an example that will clarify matters further. Since GPT's introduction, our team has been eager to explore products utilizing an LLM. We eventually developed an interview simulator based on the GPT engine. If we were to retrain the GPT model and assign it new weights to make it lighter and faster to give responses to users quicker, this would have been fine-tuning. We couldn't do that because OpenAI's fine-tuning was an experimental program inaccessible to all developers during the tool's construction. But even if it was available, it doesn't fit our use case because we want to create an interview bot that can generalize well and adapt to the changing circumstances during an interview. We aimed to enhance the model by integrating a database of sample interview questions, providing context for tailored queries based on the user's selected interview type. This led to the incorporation of RAG, with multiple adjustments made to the database during the app's development based on the model's performance. The prompt engineering phase was the most time-consuming. We had to instruct the model on displaying code questions, the types of queries for various interview stages, evaluating students afterward, the communication tone, following up on responses, and other aspects. This project indeed showed us the rising importance of prompt engineering skills and the multiple back-and-forth iterations necessary to build an AI product that behaves as expected. I hope this example clearly illustrates fine-tuning, RAG, and prompt engineering. Thanks for watching.